So, welcome everyone to the second part of these sessions. This one is about energy efficiency in heavy industry. My name is Katrine Bjerre Eriksen. I'm the managing director of Synergy. I'm just closing the door, just a minute. Which is, Synergy is an interest organization here in Denmark working on energy efficiency and was founded in 2018 by Danfoss, Grundfos, Rockwool and Velux, and today we have a number of other ambitious players within energy efficiency. The next 45 minutes we will have a discussion about how to make the ambitious goals we talked about yesterday, all the ambitions into something real, tangible, into concrete cases and learnings that you can bring with you home. First of all, we will have an introductory remark by Lisbeth Randers, who is the head of secretariat at the Callumbor Symbiosis. And afterwards, I will invite Søren Korning, SVP Danfoss Drives, and Bergen McKinnon from FL Smith, Global Director, up here to present their case, which they have brought with us today, with them today, to present to us and to have a panel discussion about learnings and takeaways on energy efficiency in heavy industry. During the session, I will open for questions from you guys, if you have any. I'll come back to that later on. And then I have to make you aware that this session is streamed to YouTube channels by the Confederation of Danish Industry and by Danfoss. And now to the introduction to you, Lisbeth. You are the head of the secretariat at the Callumbor Symbiosis. You have been working there for the past 10 years, and I look very much forward to hear your presentation today. The floor is yours.
Thank you very much, Katrine, and thank you for inviting me into this session where we're going to present concrete learnings and takeaways based on relevant cases and examples within the field. Thank you also to the organizations for putting together this very interesting panel. And I'm looking very much forward to hear what my co-panelists are going to bring to the table of interesting cases and examples. But before we start, let me just share my first thought when I saw the headline of this session, because can you really learn from cases and examples made by people and sectors that are so different from your own field, where frame conditions and local resources might differ a lot from what you're used to in your own sector? Is it possible to transfer know-how in this way, driven by cases and examples? I think this is going to be very interesting to find out during this session, and we might not have a clear answer at the end, but at least that's my ambition, that I'll do my best to inspire you and hopefully to give you food for thought to bring back home in the next 45 minutes. In Callumbor, we have the world's largest industrial symbiosis, at least that's what we claim, where 14 partners from both public and private sector are working together to share and reuse resources. Today we have 23 different streams within water, energy and materials, and the streams are being exchanged every day in an advanced ecosystem. Some of the exchanges are made in pipelines where companies are interconnected, and other streams are not physical, but mainly an illustration of the bilateral agreements between the commercial partners. Back in 2018, we had a conversion of the power station in Callumbor. That meant that the power station was doing this green transition from coal to biomass, and that inflected the whole system, the whole ecosystem of Callumbor Symbiosis, terminating some streams, but also starting others. The conversion of the power station adds up to 800,000 tons of saved CO2 emission every year, and is based on a long-term agreement between the partners in the symbiosis. So, just to state, the key principle of industrial symbiosis is when a byproduct or a residual fraction at one company can be used as a raw material or an input at the neighbor company for the benefit of economy and environment. Today, I'll leave out the gains for the local community in terms of job creation, new companies entering the area, investment in new infrastructure, education of youth, and concentrate on the decarbonization. But the other part is also a very significant part of the history. And anyway, is any heavy industry represented in Callumbor, a small town city 100 kilometers west of Copenhagen? Let me just mention a few. Novo Nordisk is situated in Callumbor, producing half the amount of insulin for the global market at their facility in Callumbor. They invest 18.5 billion Danish kroners in new facilities up until 2027. So major construction work is taking place in Callumbor these days. Novozymes is the largest enzyme production in the world, and 40% of their fermentation broth volume is produced in Callumbor. And the third example of heavy industry is Kalumbor Refinery, which is the biggest refinery in Denmark, producing approximately 5.5 million tons of gasoline and oil products annually. This is just to give you an impression of the kind of heavy industry being represented in Callumbor symbiosis. And now I want to give you some real concrete examples of how we work together and how industrial symbiosis can add to the decarbonization of this kind of heavy industry. The first example is the production of biogas from fermentation sludge, and mentioning the volume of these two big fermentation biotech companies like Novo Nordisk and Novozymes, you can imagine the volume of fermentation sludge being produced as a byproduct every day in Callumbor. This is used by a local biogas plant being built back in 2018 and run by an external company. So we do not take out the fermentation sludge to biogas plants far away, but we save the transportation by having a local unit for biogas production. And today we see new companies, new fermentation companies, like for instance the Israeli startup Remilk, placing their production in Callumbor, also due to the fact that they can actually deliver their fermentation sludge to this local producer of biogas. This is a state-of-the-art production facility where CO2 can be captured, and also the valuable phosphorus can be preserved and used for fertilizers at farmland. The second example is the use of excess heat from the wastewater in Callumbor. It is used at the local utility, where a giant heat pump extracts the heat and upgrade it to the district heating system in Callumbor. And that can actually supply 1/3 of the total demand of district heating in the small city of Callumbor. The third example is the reuse of flue gas condensate, because when we had the conversion of the power station, like I mentioned before, one of the fractions that were terminated was the delivery of industrial gypsum to the nearby company producing plasterboards, and we were sort of focused on how could we incorporate the new converted power station into the symbiosis. And luckily, we detected at a local screening that the water released when wooden chips are fired in the new building could be used at the refinery. Here it can be used for boiler water, and that covers 1/3 of the refinery's needs for this kind of water. And without this agreement and without this exchange, the refinery would have to use surface water from the nearby lake and process it itself to the required quality. So working together, the cooperation between these companies actually adds significant value and great savings for the surface water as a natural resource in the area. This is industrial symbiosis classic, really, basically. But we like to take it further than that. So we have started this new project that we have in the pipeline. We want to use the enormous amount of excess heat being available in the area, enough to heat 44,000 private households. And we have reached out to our neighbor municipality, Holbæk, because they are the biggest Danish natural gas supplied city. So why not use the excess heat from the industry in Callumbor in Holbæk? It's only 40 kilometers away. And if we can sort of integrate these two systems and do sector integration, why not? We can create a unique urban industrial symbiosis if we work together. But first we need to establish the collection of the surplus heat, and we will do that by establishing district heating for the big fermentation industries in Callumbor. And hence we can build out this system and export the excess heat to Holbæk. So working together with partners outside our own fence and should not keep us from looking into how we can optimize energy consumption in our own production, and with new partners using the network being available for us. So this is also why I look very much forward to hear the cases from my co-panelists. So thank you very much.
Thank you so much, Lisbeth. All right, now I invite Søren Korning and Bergen McKenna to join us up here. And just a moment, we have to change the gallery here. The background. Oh. So, Søren Korning is the Senior Vice President for Global Sales, Marketing and Services for Danfoss Drives. He's been with Danfoss for 13 years in various leading positions globally. And Bergen McKenna, you are the Global Director for Green Cement Solutions R&D at FLSmidth. You were, prior to this, you were heading the research and partnership function at FLSmidth Mining. Søren, I will start with you. Would you please present your case?
Yes, sure. So my name is Søren, and I come from the company Danfoss. In Danfoss, we are a technology provider. We are providing manufacturing, developing technologies and solutions for everything related to the green transition. We focus on two things. One is the energy efficiency, where all our technologies are helping a large variety of industries across the world in reducing the energy consumption and optimizing the processes. We also focus on the second part, which is technologies that are enabling the renewable transformation of the energy sector. And we have a lot of, let's say, examples where we have taken our own medicines. We have also quite a few cases in the variety of industries, as I said. And the case I would like to highlight today here is a brick factory called Vesterlet. And this is a factory creating and manufacturing bricks for buildings, for houses, you know, the bricks that we're building our houses with. It's part of the largest global brick manufacturer called Wienerberger Group. And the factory here has for many years had a high focus on reducing the energy, and I guess it's related to cost of energy over many years. It's a very energy intensive process to make a brick. First of all, you form it, then you fire it up, and after you have been firing up, you have also to dry it again with a lot of heat. In these ovens, when they fire up the brick, there's more than 1,000 degrees Celsius. So, just for that purpose, it really requires a lot of energy. They started early with energy management. They were ISO certified many years back, and have been taking this mantra of best practices. So every time they learned something here, they brought it in here. In the recent years, they have changed to biogas as the heating source for the ovens, and they have been focusing on reusing the energy. So reusing the heat, wasted heat from the oven is now transformed in and used to dry the bricks as well. And the next steps is they are now focusing on getting that, exactly as you said, Lisbeth, out in the district energy to heat up houses in the neighborhood. By these changes so far, and first of all reduce energy, then reuse the energy, they have saved 29% of their energy consumption over the last years, and that is equivalent to a reduction of 36% of their carbon emissions. And as such, it's a really good case for a heavy industry, which is typically very energy intensive, right? Yeah.
Thank you, sir. Virgin?
Yes, I think I'm going to start talking a little bit about FLSmidth and the two industries we serve to give you the context and explain the scale of events. So we serve to these two big industries, mining and cement. We are equipment and process provider. And there's a very high chance that the cement you see in these walls or the metals in your phone and in your car battery or even your wedding ring probably has been through a couple, possibly FLSmidth equipment. Mining and cement are very capital intensive industries. It creates a value chain about $500 billion, more than that. And you can imagine that with that capital intensity comes the carbon footprint as well. And if you look at the carbon footprint of these industries, cement only from the energy and fuel consumption, not the process CO2 footprint, contributes about 5 to 6% to global CO2 emissions. And it's similar, about 6.5% for the mining industry. So any kind of energy efficiency we can achieve at these types of industrial sites is very, very important and appreciated by the customers. I think we have that awareness, actually, in these industries. So I'll give you a couple examples from mining and cement industries. In mining, for the last 50 years or so, the standard milling equipment has been something called SAG mills, semi-autogenous milling equipment. And imagine 12 meters tall diameter tumbling mills. And these mills are turning slurry. And there's ore particles, there's water, and there's giant steel balls. So during that process, you also grind the steel balls that you're using as a milling help. So we are saying that now we can actually move to dry milling technologies with lower impact and much lower energy consumption. A wet processing line like that consumes about 70,000 kilowatt hours per year energy. If you would move to dry milling, say high pressure grinding rolls or vertical roller mills, then you could go down to about 55,000 kilowatt hours per year. So that's about 20 to 30% energy savings annual. And on top of it, you save your water and you save also the carbon footprint that comes with producing these steel balls you use in the old wet mills. And the payback time for renewing a milling crushing line like this in mining would be about 3 years, depending on how many of those you install and what is your capacity of the operation. That's the big saving. And then there's smaller savings, lower hanging fruits, and that comes through digitalization. Say you have one of these old mills, you can put an load sensor. We have that called Load IQ. And by measuring the load and constantly updating how much stuff you have in the mill, you can optimize that process. And that gives you about 8% energy efficiency annually, and the payback time is way, way less than 1 year. So that's something very straightforward. So those could be mining examples. And coming to cement industry, maybe I should also mention that we have a sustainability program called Mission Zero, and there we say we are going to increase the alternative fuel usage. We'll go zero emissions, and we'll go zero wasted energy. So with that, we are trying to bring more alternative fuels to the cement industry. And when I say alternative fuels, I don't mean fancy hydrogen and things like that. We are talking about bringing landfill waste and burning that as a fuel option in the cement plants. This way, you're replacing your virgin fossil fuel carbon footprint and creating, in a way, one more pass usage of the waste from the landfills. We have the technologies, we have installation examples. Payback time right now is less than 1 year because of the super high energy prices, increasing coal prices, increasing ammonia prices that our producers use to decrease their NOx emissions. The other let's say the great alternative to clinker production is using calcined clay. This way we are decreasing our process CO2 footprint drastically, because if you calcine clay, you don't create CO2 from that, and you're able to use much lower temperatures. In a traditional clinker line, you have to go up to 1400 degrees Celsius. In a calcined clay, you process at 900 degrees, and you can do the calculation how much energy saving there will be. It's much smaller footprint, smaller energy consumption, and the payback time, it's a full plant, so that is 5 to 7 years. And there are also lower hanging fruits again. Why not change your cooler to one of the new cooler ones? You will get 10% energy efficiency. Payback time is about 2 years. Change your drive, right? I guess our Danfoss friends would know about that. You will get probably 8 to 12% by changing the drive. So solutions are there, small ones, very low payback time. Of course, you can say, okay, I'm gonna just change my whole carbon footprint, and it's a bigger investment, but it's possible. We have 2 already calcined clay lines sold. It's out there, so yeah.
We just have to start. Yes,
Yeah.
exactly. Thank you so much, Bertin. I will start with a question to you, Søren. We just had a session before talking about, you can say, industrial processes and manufacturing.
Yeah.
And now we're talking about heavy industry. Do you think there is a big difference in approaching those two, because you are the technology provider and having clients within, or customers within both areas?
I don't think there's a difference to the approach. There's of course different technologies, and the biggest difference is probably the energy intensity. In majority of the industries you talk about here, we are really talking about high, very advanced processes, but also very energy intensive. So I think the knowledge and the competences around the applications are different. But compared to that, the mantra is the same. You have to define where are the quick wins. And it's not enough to convert the energy consumed from today's carbon or fossil fuel power to renewable. We can, as you had just explained, we can really do something fast which is to focus on the energy efficiency in the processes. Yeah.
So would the arguments be the same as if you approach the companies we just talked about in the former session?
I think compared to some of the more lighter industries, there's maybe not so much excess heat to reuse as an example, or reuse of the inertia in some of the processes. In the heavy sector where you have the high intensity, as you explained, with 4,400 degrees, or the brick about 1,000. There's a lot of excess heat there which can be recovered, and I think the potential there in the heavy sector is much higher.
So talking about that, increasing the waste heat usage, I think we have a great example here at Aalborg, Portland, where the cement factory produces actually the district heating. And but again, it's possible in climates like this, where the infrastructure is available and sort of implementation is supported by all parties. But otherwise, there is a waste heat in the cement plants, and it's not always utilized. It's not at the temperature that you can put a heat exchanger and recover it, let's say.
I'm very interested in this excess heat, and you also talked about it before. So how did you, you can say, overcome the barriers? Because I know there have been a lot of barriers also here in Denmark in terms of excess heat. So I guess there has been a lot of cooperation between you from the private sector and working together with the public sector.
And to be honest, I'm not sure that we overcame all the barriers yet, because we are not home safe with this project yet. But we are working together with the Danish Agency of Energy to implement the project. But I think having these experiences, working together, people from the private sector and people from the public sector, has sort of taught us how to approach each other, to respect the sort of democratic processes, and sort of maybe a little bit slower pace in the public sector, and on the other hand, understanding the drivers of the circular economy in the private sector from the public side. I think having those experiences by working together over very many years, I think that has sort of it has been giving us the guts actually to reach out to a neighbor municipality, say, if we can do this within our own local community, we can do it to a much larger extent. So I think basically this morning there was a talk about education, but I also think the sort of cross-sectoral cooperation should be a kind of a basic education for people working in heavy industry, because that is really a barrier. And if you don't respect each other, if you don't trust that this might not give me the biggest revenue in the first place, but in the long term, this is a good business case, this is the right way to go, I should take leadership on this as a global company, then I think we won't succeed.
No.
You also have some technology in Danfoss in terms of excess heat.
I would like to add here that sector coupling, I think this is what you mean with the partnerships, right?
Yeah.
The sector coupling and the district energy in some parts of the world called central energy system. Here we like to call it district energy. This is really the key for reusing the energy, and the sector coupling, where you can source various sources into the district energy grid or net, is the key. If you take Poland, they are right now out of gas, closed. Gas price up 10 times. They have no coal because they typically get that out of Ukraine. So they are really, really running at the edge of what is possible when we come into winter. If we're lucky, the winter is not minus 35 degrees, but who knows. So there they are running with post-Soviet district energy systems, where the water temperature, which is in the pipeline, is higher, more than 100 degrees, so it's steam. And here in a modern Western district energy system, the temperature of the water is maybe 40 to 70 degrees, depending on the year. The excess heat from the heavy process industry can be fed directly into these district energy. And as such, we can not only reduce the energy at the plants, but we can reuse the energy. And if you go 20 minutes north from here to Norborg, I think it's this direction, by the way. Our campus, there are 250 square meter manufacturing plant, is carbon neutral this year because of that fact. So we are reducing the energy, and we are reusing every single kilowatt hour of any kind of energy, and the rest is fed by renewable. So the heavy sector can really play a role to heat up our homes.
All right. Now I invite you to ask a question if you have one. Yes, please, and just wait a moment, and there will be a microphone.
So we can wire you up.
Thank you, and very interesting presentation. And just a comment, happy to see some women also presenting here. So good, inspiring. And my name is Peggy Mischke. I work freelance in climate finance and for the EU evaluating proposals. I'm an engineer myself and live in Denmark since 10 years and been also in the US and elsewhere. And the question I see coming in the energy efficiency world I interact with is a lot about digitalization. And my question, especially for heavy industry, bigger projects, how do you see in your day-to-day work and in your future strategy the role of digitalization to help standardize your product solutions approaches? I know FL Smith has done something also in the past years. And do
Absolutely.
you see it's easier for the bigger projects to be faster also on this waste? And where are the barriers, or what are your next big to-do lists on this journey? Thank you.
Of course, for any premium OEM provider like us, it's very important to have standardized products. And we have our internal teams doing a lot of configuration, like CPQ, that kind of activities. That's one leg of the digitalization that, creates the fundamentals of the process, how we deliver products to the customers. The other more maybe innovative part comes on as using advanced sensors. Like I mentioned, this load IQ we use is one of the examples. And then we also, for example, able to measure different liner measurements in the mills, detect cracks, simply able to predict the remaining lifetime of the equipment. So these are quite important, and there's a lot of work happening on that. These help really with the operational productivity of the sites, and we see that customers are quite interested in these.
Lisbeth?
It's not narrow on digitalization, but I think to accelerate and to speed up the circular economy, we need to share data. And digitalization can help us with that. And I think even we have a mature industrial symbiosis in Callumbor, built on trust and partners working together, knowing each other for a long time. I think data sharing is still a big obstacle, because if we don't share data, if we don't share knowledge, we will never sort of succeed with mapping the potential for new projects.
Oh. If I can add just short to what has already been said, I mean, the sector coupling requires the data sharing, and some of these sectors that are, let's say, teaming up, some of that is critical infrastructure. And that means you don't want the data in the cloud. So a lot of edge computing is happening directly decentralized in the systems. Data is shared across. I think we are under a journey there, and we need to constantly invest in how we analyze and get the most out of the data. But without the data sharing, the sector coupling is not possible.
No.
So it's a journey, and it's clearly there now, but there's a huge potential for more. Good question.
Maybe one more point to add on that. You said data and how we use that data. There are a lot of control systems installed at these plants, and if our customers were to upgrade, say, to an expert control system, they will also see a quite tangible energy efficiency in terms of their operational efficiencies.
Yeah.
Any other questions? Yeah, there was one. Please. No, it's because it's streamed, so we would like
All
you
right,
to use the microphone.
Could you speak a little bit about how to build a new industrial symbiosis place? It's a great idea once you get it, but how do you go about creating a new one?
Yeah, that's a very good question. We've developed some tools that we can apply to industrial clusters, saying how can we we shape the good ideas into genuine projects through screening and mapping of resources locally. How can we do proof of concept? How can we do a sustainability assessment? Things like that. I think we have some tools now available also for other industrial clusters that they can apply, but still a lot of work needs to be done. And I think with the new EU Green Deal, lots of funding has been put into some of these Horizon Europe programs that will add up to developing tools and share experience. But we have sort of made some generic tools in Callumbor, but of course we are sort of we are a local partnership working in a local community, and things might be very different elsewhere. Culture might be different, tools required might different, but we are starting sort of to think in system export, and right now we are doing a project in the States together with the Danish Energy Agency in Portland, Oregon, having a delegation coming to Denmark to study various industrial symbioses here in this country, and we are going back there in the fall to run a workshop and to try and see, can we actually help the facilitation of a whole new symbiosis. This is the best answer I can get. Thank you.
Anything to add? Yeah, sorry.
Initiatives in Callumbor. What initiated and has been driving it forward?
Money, basically, from the very beginning, because it was good business. The payback time was fair and attractive for companies to be a part of. But I think things have really changed a lot during the last 5-8 years because of the green profiles of the companies and the strategies of, for instance, zero carbon emission for Novo Nordisk and Novozymes. So the fact that they have been taking the leadership and saying we should support the green transition by taking the first step by having the guts to step out in the open, say we believe in this local partnership, we put resources in it, and we dedicate our staff to actually mature projects. So I think in the beginning it was the good business case, it was the money driving the different projects, but today we see the green agenda also being very, very important for the companies to tap into. I think we even see companies entering the area of Callumbor immediately tapping into Callumbor symbiosis and embracing the idea of being a part of an ecosystem, saying this is a value proposition. So it sort of adds up to the success of the partnership, really, when somebody from outside says this is attractive for us to be part of. So it sort of encourages itself, I think.
One last question.
Build off of that. It's nice to hear that the business case makes sense and that there's also incentives to help drive the transformation. Are there also regulatory or policies that Callumbor has implemented to help accelerate the transformation?
In our case, no, but maybe in other areas, I think I know, for instance, that Washington State in the U.S. implemented a law supporting industrial symbiosis, promoting these kind of initiatives. So it's difficult for me to give a generic answer, but I think also without financial incentives, it can be possible. I think you should start simple. Do one project, add another one, build out your ecosystem, hook up with somebody who has the charisma and the guts to take the leadership in the local community, and grow your own symbiosis. That would be my best advice.
Yeah.
Thank you so much. So actually we are very close to an end now already. Time flies when you're having fun.
Before you close
Yeah,
it.
no, I don't close it yet. But
I just want to highlight that there are some of these cases described what is done. You can take them. And I also believe there is a chance for field trips to, among others, the brick factory today actually. So
exactly.
feel free.
That's a good point. I'll come back to that as well.
Sorry then.
I have one last question. So if there is a company within the heavy industry that would like to start looking into energy saving potentials, what would your advice to them be? So, Sonna,
I
like
don't want to say call Danfoss. But no, I think. Can you start?
I'm gonna say call FL Smith. Definitely. I mean, we are there as the knowledge partner and wanting to guide our customers in the right direction and show potential solutions, right? Because solutions are there.
Yeah.
It's.
I think. I mean, the industries they serve, there are nobody knowing their processes better than them. So I think the key is energy management. Define where in the process is the biggest, let's say, chunk of energy, and break it down bits by pieces. You can't take a full cement plant in one go. You have to really take step by step and then find the quick wins. That would be my recommendation.
And my answer almost similar. Partner up with the experts because you might not be able to achieve this yourself. We heard that this morning as well. Partnerships, whether they are local or with experts in the fields, they are the key to reach that goal, I think.
Yeah.
Very good. Thank you so much to all three of you.
And for the questions, not least.
Yes, exactly, and thank you so much for you to be here today, to listen in, also on online to those that have been online. A few practical information. Next is lunch. It's served in the lower lobby where we were in the beginning of the day, and after that, it's site visits. Buses leave outside Allison, just down here, at 12:45. And there will also be people around here to guide you to where to go. And if I should say a few things about the takeaways, I at least have here from your discussion is that there is a lot of energy saving potentials out there. It's money talks, but also that there is also a wish to become carbon neutral now, and that has actually changed for the last at least 5 years. We have to work together to overcome all the barriers and to become carbon neutral, and that the excess heat is part of the solution when we talk about heavy industry, and also that we need leaders to show the case and how to implement it to actually reach our goals. So that will be the final words from me. Thank you so much for being here, and have a good day.
Thank you.